Quick flashback. 2 videos ago, most of our files had no directive at the top and just worked. Then we hit Create Project button, and suddenly, we needed Use Client or Use Router would break. I told you we'd explain that properly. Today's the day. This is the concept that makes Next.js fast by default, and it's also the single most misunderstood part of the app router. Get it wrong and your bundle size balloons. Your pages feel sluggish, and you'll be sprinkling Use Client on everything out of fear. Get it right, and most of your app ships 0 JavaScript to the browser. By the end of this video, Taskmaster will fetch real project data directly inside a server component. No use effect, no loading spinner state, no API route required. And we'll wrap a slower section in suspense so the rest of the page doesn't wait on it. Let's get into it. Server components are the default. The mental model flip. If you're coming from classic React, this is the part that needs rewiring. In the app router, every component is a server component unless you say otherwise. A server component runs on the server once per request. It renders to HTML on the server and sends that HTML to the browser. No component code, no React runtime for that piece, ships to the client at all. Just the output. Look at app-dashboard-page.tsx from video 2. No use client, no hooks. It's a server component right now, and you didn't have to do anything to make it one. Why this is a big deal. 3 concrete wins, and they're the actual reasons this exists, not just theory. 1. 0 JavaScript shipped for that component. Smaller bundles, faster page loads. 2. Direct backend access. Database queries, file system, secret API keys straight in the component, because it never runs in the browser. 3. Data fetching without the use effect dance. No loading state, no race conditions, just await. Note: server components never re-render on the client. If a server component needs to change after the page has loaded, that's a job for a client component wrapping around it, which is exactly why the boundary matters. When you actually need Use Client. Remember Create Project button from last video? Let's look at exactly why it needed the directive. Use Client, import Use Router from Next-navigation. Export default function Create Project button, const router equals Use Router. Function handle create, router.push dashboard projects 1, return button on click handle create, new project button. 3 things in this file are the giveaway, and they're the entire checklist for when you need Use Client. 1. On click, any event handler. Click submits changes. The server can't listen for a click, only the browser can. 2. Use router, any hook that touches browser state. Use state, use effect, use router, use context for client state, all require a live component in the browser. 3. Browser-only APIs, local storage, window, navigator, none of these exist on the server. Note: if your component doesn't do any of those 3 things, it doesn't need Use Client, even if it looks interactive on the page. A component that just displays a hover-styled card with pure CSS still doesn't need it. CSS runs in the browser, regardless of where the HTML came from. The boundary rule, here's the part that trips people up. Use Client doesn't mark a single component as client only. It marks the start of a client boundary. Every component that file imports and renders becomes part of that client bundle too. But it's not viral in the other direction. A server component can still render inside a client component if you pass it in as children or a prop. That server component keeps its server-only powers. It's just being placed into a client-rendered shell. Rule of thumb: push Use Client as far down the tree as possible. Don't mark a whole page client just because one button needs a click handler. Server-side data fetching. Hands-on. Right now, app dashboard projects, page TSX, just returns a hard-coded heading. Let's make it fetch real project data, the way you'll fetch from Postgres, once Prisma is wired up in video 5. Step 1. A mock data layer. Create lib.data.ts. This stands in for a real database call for now. Export type project. Name string. Status. Active. Archived. Export async function get projects. Promise project. Simulates network database latency. Await new promise resolve. Set timeout resolve. Return 1. Name, marketing site redesign. Status active. 2. Name mobile app backend. Status active. 3. Name Q1 reporting dashboard. Status archived. Step 2. Fetch directly in the server component. Update app dashboard projects. Page TSX. Import get projects from @libdata. Export default async function dashboard projects. Const projects equals await get projects. Return H1 class name text 2XL font bold MB4. Your projects. Yule class name space y2, projects.map project, ID, class name border p3 rounded, project.name, span class name ml2 text sm text gray 500, project status. Span, notice what's missing, no use state for the projects array, no use effect to trigger the fetch, no isLoading flag, no error boundary boilerplate. The component is async, it awaits the data and it renders. That's the whole data fetching story in a server component. Note, this only works because the component itself is a server component. Try making a component both async and use client, and Next.js will stop you. Client components can't be async functions. Streaming and suspense boundaries. Right now, visiting/dashboard projects makes the whole page wait for that 800 millisecond fake delay before anything shows up. Sidebar included. That's not great. If one section is slow, it shouldn't hold the rest of the page hostage. Suspense fixes this by letting you stream the page in pieces. Wrap the slow part. Update app dashboard projects page tsx to split the data fetching into its own component or wrap it. Import suspense from React. Import get projects from @libdata. Async function project list. Const projects equals await get projects. Return all class names space y2. Projects.map project. Class name border p3 rounded. Project.name. All class names space y2. h1 comma dashboard projects. Return into div h1 class name text 2xl font bold mb4. Your projects. Suspense fallback channel text gray 400. Loading projects.p. Loading projects. Reload the page. The heading and layout render immediately. The loading text shows exactly where the list will appear, then swaps in the moment the data resolves. The sidebar and heading never waited on it. Note, suspense boundaries are the reason you'll see skeleton loaders scoped to specific sections of real production apps instead of one full page spinner. Wrap anything slow, a report, a chart, a comment thread, in its own suspense boundary, and the rest of the page stays responsive. Call to action. Let's lock in the mental model. Server components by default. Fast, direct data access. Zero client JavaScript. Use client only when you need interactivity, hooks, or browser APIs, pushed as far down the tree as possible. And suspense to stream slow sections, without blocking the rest of the page. That's exactly the foundation Taskmaster needs, because in video 4, we're wiring up a real PostgreSQL database, and everything you just learned about server-side data fetching is about to become the real thing, not a mock. If this helped, like the video, drop a comment with the one server versus client component question you're still not 100% sure about, and subscribe so you don't miss it.